All right. Well, everyone, it's so lovely to have you today. Joining and thank you for joining us on how oil and gas companies leverage their industrial IoT experience to drive it. I'm the moderator, Joyce Dooley, senior analyst at Z Prime Research and founder of the Smart Texas Alliance. I'm very excited about our panel today. I think it's going to be a fantastic discussion. Just a couple of quick housekeeping items. We will be holding questions until the end. So if you don't mind, just go ahead and drop your questions in the chat and we'll get to them as soon as possible. But before we get in a little bit further, I would love for the panelists to take a moment to introduce themselves. Danielle, would you like to kick us off?
Sure. Am I off mute now?
Yes.
Just switching around my camera view as you were introducing me. My name is Danielle Jablansky. I'm a senior research analyst at Guidehouse, and I actually focus on cybersecurity, but also helping clients leverage their networking needs to adopt IIoT in industrial environments. So I'm really excited to join this group, and a special thanks to HiveMQ for sponsoring.
Well, we're very happy to have you here. Thank you for joining us. Toby.
Yeah, hey everyone, Toby Summers, Houston-based. I am a managing director from EY. I focus on advanced analytics, data science, and digital transformation for our major oil and gas clients. Look forward to the session today.
Awesome, thank you. And Dominic.
Hello, everybody. My name is Dominic Obermeier. I am the CTO at HiveMQ and also one of the co-founders. And so we are helping companies move their data where they need to be. So, for example, a lot in the oil and gas industry. So looking forward to the conversation today. And yeah, thank you.
Awesome. Well, now that everybody kind of knows who everyone is, we'll go ahead and get started. So the first question I have is, what are the greatest challenges hindering technology adoption among oil and gas companies, and how can companies overcome them? Dominic, would you like to take lead?
Yeah, so thank you for this question. So this is it's a pretty good one. So we work with a lot of clients in the oil and gas industry and the energy sector, and the challenges changed a bit. On the one side, they changed, but they also did not change over the years. So one thing that changed though is that a lot of insight into the business is required and also into the data. And a traditional problem is that a lot of data silos are being used. And one of the key things we noticed, which in the last few years really got acceleration, is that companies are moving to completely decoupled architectures that allows them to move data freely and bring the data where they need it, and this basically in real time. So for example, we know companies who sometimes almost need an hour before they even take the leakage into the wellheads, which is a major problem. And with these real-time data architectures, this is something that can be overcome. And this is something we're working on with customers. So it's not a new problem, but the technology evolved a lot, and the move to this kind of so-called publish-subscribe architecture, where data can be moved in a push direction, in a push way, really allows kind of real-time experience and bring the data where it needs to be, and basically breaks up the data silos, which is a very tough problem to solve. But this is something that is being worked on by a lot of companies right now. And yeah, looking forward to also share more experience on that.
Awesome. Thank you so much for your insight. Danielle.
Yeah, so I'll just share two quick things that I've seen. One is that there's a shift right now that in the proclivity to build in-house versus buy commercial off-the-shelf products. We're seeing a kind of a new phase where clients are more willing to actually buy that commercial software and integrate it into their networks. And then on the networking needs, the scalability of existing networks is kind of being challenged, I think, with these new data technology and applications. And so we need more robust wireless networks out there that can actually scale to meet the needs. And then the last thing I will say is that investments at this point, something hindering the technology is that there's this need to kind of hit three different nodes when investing in something new. And that's, there's utility for business functions, there's utility for customers, but there's also a utility in that application for green energy. And the pressure to hit all three, I think is sometimes hindering new technology adoption.
Thank you very much. Toby.
Yeah, I think I'll echo some of the points already made, but certainly we see it as an ROI question, right? So what's the value of, investing heavily into especially a brownfield asset base that may or may not provide the immediate ROI, and certainly it's hard to justify a large investment. So that's one hindrance. One, sort of one way to overcome that, and one thing interesting, much to Danielle's point, the availability of off the shelf and certainly through public cloud providers is becoming much more democratized. So I think the ability to access new technologies is accelerating. I think that certainly with these sort of open ecosystems, more sort of services-based approach allows sort of the quick adoption and incorporation of those capabilities within the networks of large IOCs especially. So we'll see. It's certainly an interesting journey. Things have changed, though. I think at the end of the day, it still very much comes down to that ROI, and and I guess the other challenge that we see, the more you rely on these sort of quick actions and automation more and more, the more the network becomes really a core capability that can't fail. So if it fails, all of a sudden things break as you pull more and more headcount out of the field. That becomes more and more critical that works in all times. So that's certainly one we're seeing. But obviously with the edge, the ability to run disconnected is certainly going to become really important. So we see advances in AI helping with that. So great question though.
Yeah, thank you so much. Moving towards the business side of things, what are some of the business decisions or incentives that drive investment in oil and gas right now? And are you seeing rollouts for innovation's sake or for business cases driving implementations? Danielle?
Yeah, so this is a great question. We're seeing production sites onshore and offshore wells, refineries, and factories all kind of looking for end-to-end solutions on top of traditional networking infrastructure, which I mentioned before. And they're especially looking towards those that include data analytics capabilities. Like Dominic mentioned, they want a repository for integrating their data and storing it as well. They're also looking for ruggedized solutions to meet the needs of some of the more rural areas of their operations. So we're seeing a new embrace of agile development and modernization, which a lot of manufacturing has been embracing over the last 10, 15 years. We're seeing that in oil and gas. But they're focusing on solutions that reduce downtime. I think Toby started to allude to that, reducing expenditures and then enhancing the procedures for maintenance and upgrades. So beyond that, a lot of the solutions that are being offered right now are centralizing the command and control across those operations, but also incorporating big data, machine learning, and analytics. Like Toby mentioned, looking towards automating processes based on certain conditions within an operation. A lot of focus on health and equipment and things like predictive maintenance and analysis. But then something that doesn't get mentioned enough, I think, is replacing kind of the mundane and time-consuming tasks with sensors and readings. You don't actually have to always look towards, robotics or the latest and greatest to save a lot of time and money. I could go on and on about this one. So the last thing I will say is there's just a lot of cool things going on around the sensors that are out there for sound and acoustics and things like, high resolution reservoir data that we're getting, 4D modeling, and, everything down to another mundane processes, just kind of tracking the movement of trucks in transit. And once all of that rolls up again into that command and control infrastructure and architecture that I mentioned, we can really see a lot of integrated solutions. But I will caution people, just to end, when they are looking at purchasing a solution, really push on what they mean by end-to-end, right? Because not everything is connected and not everything should be connected. So I would really drill into that buzzword. So thank you.
No, excellent point. Thank you, Danielle. Dominic.
I think Danielle raised a lot of very, very good points. I would like to expand on some of them. So what you're seeing a lot is that remote monitoring from a central location to reduce the costs and increase efficiencies is also something that we see a lot currently. And again, this is not something new, but a lot of investments are being done here. And in the end, it's all about cost reduction. So also something when it comes to the remote monitoring, this traditionally is pretty expensive and also based on the technology used. And a huge driver in cost savings is actually reducing the bandwidth and the network costs. And this is especially true if you have remote sites and remote areas you want to cover. Also, especially if you're using VSAT, this is like satellite communication. This is really expensive, but also mobile coverage is pretty expensive. So this is why also new communication protocols and paradigms like MQTT as a very important technology in the space, is basically replacing Modbus-based architectures, and which not even allows only to use less bandwidth, but this also allows to use this kind of push paradigm where you get the data where needed. And I think I mentioned this before. One example I found noteworthy is when it was for a company pretty hard to understand when there were any problems, which also caused environmental concerns, because if you have a leakage in the wellhead, this is not something you really want to have. And you really want to have the data that something bad happened as soon as this occurs. And what a lot of companies were doing traditionally is to reduce, let's say, the sending of data basically to a minimum in order to save costs. But the cost of that is basically not getting real-time insights on what's happening. And this is why new technologies like MQTT are needed. And this is also why a lot of companies like Chevron, for example, are very successful in deploying MQTT-based architectures for exactly solving these kind of problems.
Great, thank you so much. And Toby.
Big points by both. When it comes to sort of, leading by business value or, sort of technology for technology's sake, certainly the successful ones we see happen when, led by the business, right? When there's a real value in implementing these technologies, having a use case in mind. But then the great thing we're seeing happening is once that investment is made for a particular use case and it has its own ROI, the expansion into different areas. So, now that you have sensing, what else can you do? It's certainly a really great way to hit maybe some of the lower ROI, to Daniel's point, some of the things that are maybe a bit more mundane, but now that you have, full visibility to your operations, you could do more things. So certainly a trend that we're seeing pick up pretty quickly. And again, back to just availability of different technologies, more democratized. I think we're seeing that filter down even beyond the big guys, down into the smaller operators to be able to take advantage of new tech.
Thank you, Toby. So, as we see that data has become kind of a crown jewel asset, how are oil and gas companies modernizing their technology and business models? Toby, do you want to kick us off?
Yeah, glad to. I think, when you think about managing any of your other assets, you've got whole organizations that day in and day out, that's what they do. They manage those assets. We're seeing data being treated that way now as well. That data truly is managed as an asset, as a set of products with, capabilities, SLAs, sort of even almost like terms of use. You have to establish sort of guidelines in terms of how the data is used, what it's used for, what it's not used for, what it's suitable for, and frankly, what it's not, because I think you can, as much as it can drive good decisions, the wrong data and the wrong perspective can actually, be quite a negative. So we're seeing it, really being treated as such in sort of quite a few operators now, that it truly is becoming managed as an asset and frankly, a key differentiator.
Thank you. Danielle?
Yeah, so something that Toby mentioned earlier was the embracing of cloud computing, but that's also not something that you just buy off the shelf and you're ready to use. What he was just alluding to is the development of strategies for data coordination and use. And we're seeing that as a pivotal point right now, especially after the pandemic really surged the remote access, right, and remote users for a lot of operations. I know that I said sensors and kind of mundane operations and data coordination and data lakes and things like that are really on trend right now. I do think in the future that robotics and drones, actually drones is a huge uptick right now, actually in oil and gas, but AI and robotics, which I think is a panel later today, will really start to take off in maybe about 10, 15 years. But also something we're seeing is cost savings as being reinvested with technology adoption. So a couple of examples being companies that cut down on their energy consumption, then reinvest those by using data analytics to cut down on the energy that they use and reinvest their savings into new technology projects or green energy. Another example is, retiring old software and becoming more efficient. Another thing we're seeing is a lot of mergers and acquisitions, right? And so instead of building it in-house, they procure, smaller companies or software. And that can be either strategic or for utilization. So sometimes it's just to kind of signal to the market that they have that capability. And other times it's really to, reverse engineer and build something robust from within. The other thing I will say is that, as Toby mentioned, there's a lot of technologies right now that are enabling more real-time data analysis and day-to-day decision-making, and that improves efficiencies as well. But one thing I can't not say as a cybersecurity person is that prioritizing cybersecurity on top of all of those investments in strategic planning is really pivotal and key. And that's my bread and butter. So I have to, give it a nod.
No, thank you. I mean, I don't think that we can ever really forget about the importance of that, especially as we continue to make things more distributed and, connected at the edge and all this other stuff. I mean, it's definitely something to keep top of mind. So thank you. Dominic.
Yes, this is some very good points, and especially the cybersecurity one was very good, because I still think that some companies had not yet realized that security is not a feature. This is like table stakes. This is also very fundamental. You cannot add security later on. This is really, you need to incorporate that in a way of thinking how you design your data architectures. So I think this was a very good point here. Because the truth is, if you look at what companies are doing today, there is still a lot of room for improvement when it comes to security. I'm sure we'll talk about this later on. And so especially if companies are moving to new data architectures, it's so critical that they basically build for security in the beginning. This cannot be an afterthought. So this was, I really enjoyed that point Danielle raised. Also, one thing, and I think this is also what Toby mentioned, is there are a lot of data silos. So, and in order to make use of the data, you need to basically free the data from data silos. And because if you have your new fancy cloud architecture, this just doesn't work if you are not able to bring the data where it needs to be. And if you look at analysts like Gartner, they say today, this is not oil and gas specific, but this is more IT industry specific, but I think as are interesting insights also for oil and gas. Currently, 90% of data that is being produced inside clouds or data centers. But we are now seeing a major shift towards edge computing, which means most of the data is being generated outside of the data center. But we also heard about things like data lakes and other basically big data technologies. Usually you want to have decentralized data. So a key challenge is, how do you bring the data as efficiently and as securely as possible to where you need the data? And Gartner, if you believe Gartner, they have very aggressive numbers here. They say almost 80% of all data produced by 2025 will be outside of a traditional data center and cloud. So we have a huge gap here of where data is produced and where data needs to be. And what we are seeing right now is, especially with oil and gas, you have this kind of edge architectures where you do have cloud computing, where you basically do all your, let's say, heavy crunching and so on, and also have your basically business applications. But also you have local deployments where you build these tiered architectures where you can basically enable real-time communication on site, but also bridge data in the frequency, for example, you need it to the cloud and so on. And this also allows for some pretty interesting architectures, which allows to have secure cloud connectivity while not be able to have all sensors securely. Because if you just put in a sensor and connect it to the cloud, chances are that at least some of these vendors might have an issue at some point of time. So it's really not a good idea to connect everything to the cloud directly. You really want to have a tiered architecture with proper permission settings and so on, and also design the data flow end to end to make sure you don't get a problem here. And then you can also, and this also allows you to take care of security, especially if you go into the permission models. But yeah, security actually is a large topic. So there are many ways for this, but I think if you have a tiered architecture, you get a lot more options than if you just pump everything to the cloud.
No, I mean, I think that that's a really great, point to make, and definitely, what needs to be connected and when and how are definitely important things to keep in mind. Toby or Danielle, do you have anything else to add to this before we move on to the next question? Awesome. Okay, great. So the next one is, what are some of the current OT IT convergence challenges for oil and gas companies, or that oil and gas companies can experience, particularly as things shift to cloud and move from a CapEx to OpEx? Toby.
Yeah, glad to take that one. Good question. I think actually carrying on from Dominic's answer from the previous question, very much we traditionally have a tiered architecture in the OT world, and frankly, it's been built up over decades, right? So you've got sensors and different systems that collect the sensor data, then you've got historians that connect to that, and then those have been again, it's taken decades to get those to a point where they're trusted, where they're secure, and remain isolated. And that sort of isolation is the typical approach that many operators have taken and still carries on today. The challenge has been, from the cloud top down, that you've got more and more ways to drive insights using that data with cloud technologies and even other data lake technologies and data centers. There's been a real sort of, I guess, a bit of friction between those two areas, and it kind of remains sort of part of it's just the traditional change challenges around cost. Certainly, it's a bit around culture as well. Just that folks that run the OT really don't want the IT guys coming in and telling them what to do, and don't want to sort of create new risks into their systems that don't exist today. So that's certainly been a challenge. And then as we shift towards more cloud technologies, we'll likely see the unwinding of that traditional approach. And to Dominic's point, more of a tiered architecture where you can keep the OT secure while still driving value with new technologies and new ways to drive insights. So it's certainly a long march, but we're seeing good signs that I think that's going to unwind soon. And again, with sort of value and cost and some of the key business drivers being the enabler for that.
Awesome. Thank you so much. Dominic.
Yes, well, there are some very good points also raised here. So the conversions of IT and OT is, I think this is a classic topic, but I really do think, and we've seen this in other industries before, that there is like this very famous quote from Andreessen, not Ben Horowitz, from Mark Andreessen, very famous venture capitalist who basically built Netscape back then. And he said in 2010 famously, software is eating the world. And this is true. Like we have seen in the last 20 years, software is eating a lot of industries and traditional approaches. Why? Because the agility you get with IT is something is incredible. And if you look at different vendors, and I mean, I'm here based in Germany, just if you look at a very, let's say, also famous vendors like Siemens and so on, we have also a lot of other very important players here. They are shifting towards IT architectures, even on their traditional OT hardware. So basically what's happening is everything is driven by software. And there's a lot of opportunity in that, but there's also some risk in that. And this is something that is, I think, pretty important to consider. I do think that the clash between OT and IT will be increasing because this is, I think, what Toby also mentioned, that a lot of the business drivers are coming from the IT side. Also, IT budgets tend to be higher, depending on, of course, the company. But a lot of the innovation is driven by IT. And there's so much business value here. So I'm curious how this plays out. I don't know. I personally am a strong believer that IT will, basically in like 20 years from now, really eat a lot of traditional OT functionality. But again, this is something I just don't know. This is just what I'm observing because the trend is massively shifting here, but I'm curious to see how this plays out in the end.
Thank you. Danielle.
Yeah, so again, I think that cybersecurity is the biggest challenge for the IT-OT convergence conversation, but also protecting personal information, business information, and IP. We've seen incursions, with ransomware for money, but we haven't really seen a lot of IP indicators that those things have been held hostage. There are a couple cases that are out there that like these files have been allegedly posted to different dark websites and things like that, but we really need to look at IP a little bit closer. Something that wasn't mentioned, I think that is a big hurdle is actually testing and change management, right? There are really long-term processes for altering anything in an operation that has dynamic ongoing, physical processing happening. And we can't lose sight of that with more investments in IT. But I think actually the best way to overcome those challenges is actually to just replace the IT-OT convergence debate with conversations around safety, because we know that brings IT and OT people together. And we know that also recenters the conversation on that monitoring of physical processes. So as robust and iconic as your IT business cases can become, you can't forget that dynamic processes at the end of the day are what drives safety in your operation, and that's what's most important to secure, however you secure it. So that's kind of my spiel, but as Dominic said, we could probably have an entire day based on the IIoT talk and convergence.
Most definitely. I think that that's definitely a meaty topic to dive into. And Danielle, I think you're really going to enjoy this next question then, considering your bread and butter being cybersecurity. So I'd love for you to kick us off with, cybersecurity is always an important consideration. Is there more real-time connectivity? If there is more real-time connectivity, what are the key considerations companies need to understand?
Yeah, so I think there are a couple sessions on this later today as well, and I'm excited to tune into those. The new buzzword, I love to kind of unpack buzzwords, I think, is visibility is king. You need to know what's on your network, know what data communicates where, when, and why, and know what connects to the internet, right? Either directly or through a third party. And in these operations with multiple vendor products, it's really difficult to do that contact tracing to not, hit on a sensitive node. But what's really interesting about the tiered architecture perspective is that there's a policy called least privilege access throughout OT systems, and we need to bolster that, I think, and make sure that runs all the way through the enterprise when it comes to, again, physical processes and physical monitoring of operations. We know that more devices and more data, means more attack vectors, but it doesn't necessarily mean you're more insecure if you're actually managing that risk, right? One thing for this conversation, back to kind of the IIoT perspective, is that IoT is inherently simple and less secure, and so sometimes those devices are built to connect to any network at all that it can detect, kind of like a beacon. And so again, we need to manage that risk and prioritize mission critical systems, which is something that we harp on in OT cybersecurity over and over again. That is our crown jewel analysis. But if you don't know what's connected where, when, and why, then you can't begin to prioritize those crown jewels. So it kind of is a cycle that you have to go through. It also requires investment, staff, and training, which is another day-long conversation that we could have in this field that I could also harp on. But so if you're talking about cybersecurity, why are we connecting what? What are the user requirements for that business case? And then is it a crown jewel asset? Where does it live on the network? Is there a firewall? Is it behind the DMZ? Do we follow the Purdue hierarchy? Those kinds of things are again dynamic, which is like my favorite word today. So it's not static. You can't just do it once and can check the box and consider it safe and secure. It needs to be dynamic. And then once you get into some of the encryption conversations around the technologies and the simple sensors that you're embedding, again, you have to kind of balance that risk. So at the end of the day, I would just make sure that integration is really, really critical for your business function. And then, like I said, start that cycle of securing and continuing dynamic analysis of what you have.
Excellent. Thank you. Dominic.
So yes, as mentioned before, security is really table stakes and so important. And I fully agree what Danielle said here. And I'd like to dive into one specific topic a bit more. It's a bit more technical. And this is the way of thinking how we connect devices. Because very traditionally, how architectures look like is you have a device that is producing data, and then some system goes to the device visually and pulls the data out, which has different problems. So especially if you do this locally, everything is fine. If you do this over the internet, you get a lot of different problems. Number one is access control. So who can access that directly? This is a major issue. And a second issue, which people sometimes don't appreciate enough, is that especially if cryptography is involved, you usually have some devices who have limited computing power. And if you have access over the internet, you get access over the internet, even if you cannot connect to the device securely and the device is blocking you, there's still computing cycles wasted. And if you have enough people basically bombarding the device with with requests and say, okay, give me your data, and this is blocking you, what could happen is you have a so-called denial of service attack. And this is something that has been experienced by a lot of industries recently, because if you just have it open and you have it securely open, still if somebody is like bombarding that device, you're getting a problem, because while the attacker cannot go into the system, it can at least make sure that this doesn't work. which is for a business perspective, this is not good in most cases, to be a bit optimistic here. So you really want to avoid that. And so what is really interesting, this is also why, for example, Chevron switched to a Spark-based architecture, which is a communication protocol based on MQTT, is you switch the way how you have data. So you build a central data hub, which you can secure. You have policies and so on, which usually also runs on IT hardware, which is hardened, and then you have the devices connect directly here, and the devices initiate their connection, so they can connect, and then they can push data as needed. And this is a paradigm shift on a so-called publish-subscribe architecture that is being used a lot. If you look to manufacturing, a lot of people are using this kind of architectures right now. They migrate away from classic request-response architectures because they face similar issues. And now with oil and gas, we see exactly that. And a lot of companies are successful. There are success stories, for example, Chevron, who share that publicly, what they've done. And also, by having this kind of architectures, not only to have a more secure architecture, but also they have a decoupled architecture, which allows them to consume and produce data freely without having this, what I call spaghetti architecture, where you connect everything with everything. And then the question is, okay, what device can communicate with what device or with what system? And then you get into observability nightmare, and you really want to centralize that. So this is something we see a lot, and also something we work with companies to achieving that. And the cool thing is you don't even, you don't need to replace your old architecture. If you go to this architecture, you can build this in parallel, and you also have a very good bridge to the cloud already, because this architecture allows you to having this kind of tiered architectures, this kind of data filtering, and you can bring the data where you need it to be. And you basically have this real-time experience where you can send data in a snap, because as soon as data is produced, everybody gets notified about the data, and you don't need to pull the device. So this is something, we see a lot. Is also something we work with companies for achieving that. And this is saving a lot of costs and also resolves a lot of security headaches. Not all, of course, but at least you're getting rid of some attack vectors, but not all, of course.
Thank you so much, Dominic. And Toby.
No, those are great points. I don't have a ton to add. In fact, Danielle and Dominic are way deeper in cybersecurity than I can ever be. So I appreciate their insights. I would just add where Dominic was going about the architecture. Certainly we see sort of the push architecture from the edge really picking up steam, as he's mentioned, as well as sort of the contextualization layer, where we see another layer of abstraction for that definition that allows sort of deployment at scale, right, across sort of the almost a taxonomy-driven architecture that allows you to define characteristics of your underlying sensors and tags, and then deploy use cases, more as a templatized approach. And again, going back to security, it certainly allows you to distinguish between the two and allow sort of the data to be pushed out and managed that way, rather than, I completely agree. We've seen the DDoS pick up on those edge devices, especially as, even some of the fixed camera and some of that stuff that, can easily be undermined by those sorts of attacks.
Thank you. I think this one will probably be a little bit more in your wheelhouse then. So what additional technologies might benefit from IoT integration to provide greater ROI? For example, I think you mentioned AI a little bit earlier, but such as digital twins, machine learning, et cetera.
Yeah, we're back to once you've established that underlying foundational architecture where you have now sort of visibility of your operations at scale. We're seeing a massive uptick in the adoption of AI, lots and lots with digital twinning. That's the idea that you can run simulation against lots of different scenarios. Certainly that gets into fault prediction and sort of failure prediction, the ability to, again, at scale, innovate, create a capability, and then deploy to your entire fleet. So lots of uptick there. And I think the use cases are almost endless when you start thinking about remote ops, when you start thinking about, what can you do with, I think Danielle mentioned audio signals as well as, so video. So now if I have audio video feeds, whether it's a fixed feed or via a drone, what else can I do? I can see my operations. I can see what's going on. I can start to pull people out of harm's way and not have to send them out to a particular site to do an inspection, right? I can send a drone or have fixed cameras and audio sensors to to sort of understand what's going on. Again, allows me to run my asset centrally. And again, that drives a massive ROI. Every mile driven, is both risk and cost. So if I can sort of pull that down, that's certainly a good thing. And I can sort of increase my asset base and keep headcount flat or even pull headcount down, through natural attrition. But no, great question. Thanks, Joy.
Yeah, no, thank you. We really appreciate your perspective. Danielle.
Yeah, so I just want to go back to the last question really quickly, because I really thought Dominic's description of the architecture was brilliant, and also because none of us use the word segmentation. And I wanted to highlight the fact that when we look at segmentation for new technologies and kind of advancing architectures, a lot of folks think that segmentation can only be done system to system, but you can actually do credential-based segmentation, you can do physical location segmentation, and then leading into this question, you can actually then kind of jump the hurdle that I mentioned on change management and modeling and testing by using technologies like digital twins to go in and do scenario-based assessments of your operation without having to go through those full testing and change management processes. And so that convergence of technology that we're seeing and some of those different solutions is really cool. There's a lot of cool technology being made by really smart tech people. But at the end of the day, I think that we really have to go back to that focus on user requirements that we've all kind of touched on, and the use cases and the business functions, because I actually think that it's more likely that there are dozens, if not more, of technology solutions that have yet to be created based on the needs of this industry, likely hundreds actually. And so we need to be really specific and choose wisely when it comes to meeting those user requirements. But things that converge those packages or suites of technology, like Toby was mentioning, the video feeds or the sonar, as well as the digital twins and the modeling and simulation. I think investments in that are going to then spawn the creation of those solutions that we don't even know exist yet, that haven't been created.
Awesome, thank you. And Dominic. Oh, I believe you're on mute.
Okay, sorry. So I would like to add an additional perspective here on that question, which is basically two things, especially because a lot of investments are being made right now, and this is, I think, good. I sometimes have the impression that not all companies are forward looking into the next years, like 5 or 10 or 15 years, and how the data architecture will evolve. And one of the things which people from the IT usually know is that open architectures are extremely critical. So if you look at the internet, like where we started connecting things, basically, what in the end won and was the industry standard are open standards, what everybody uses today, like TCP/IP and so on. And if people remember back then, TCP/IP was not the main competition, and nobody believed back then that TCP/IP would basically rule the world. Some did, and companies like Cisco, for example, they made a pretty good bet, and are now also they've done pretty good over the last few years because of that bet. But other technologies, they disappeared, especially proprietary technologies. And what I observe is that some companies are thinking about proprietary technologies, are investing in proprietary technologies, and so they go into a huge vendor lock-in. And this is on different levels, and the same basically is true for clouds, because what happens a lot is that people choose strategically a cloud vendor like Google, like Microsoft, like Amazon, and then they build the services based on proprietary solutions, like the machine learning solutions and so on. It's easy to get started. The proof of concept is very easy to be made. But two things to consider on the one side are the costs, because you usually have a dynamic cost model, which is for proof of concepts, it costs you basically nothing. But if you're going to production and your data grows and grows and grows, basically your bill will grow. And this is something that needs to be considered in a ROI calculation. This is something we see a lot, and also the technology lock-in. A lot of companies are now going the route and using proprietary protocols to connect their things. And it's not even clear if 15 years from now that this technology is still there, that the vendor is there and so on. So I would really urge companies to think about open standards and use really standards and not just some some things that look like standards. And we see this a lot. And this is a mistake that has been made in IT so many times. But I really, it would be a shame if a lot of companies are falling into a trap here. Because also, since our company is also not only working in oil and gas, but also with a lot of companies more on the IT side, like the automotive industry, we also see a bit where the different industries, what let's say the maturity when it comes to the data platforms, where they are. And I think the oil and gas is really catching up here, but still a lot of investments need to be made. I think this is still very early days, but I think this was mentioned multiple times today. But this is accelerating, and this is pretty good because the digitization you basically are doing here can really be a competitive edge for companies.
Great, thank you. Before we move on to our final question and open it up to audience Q&A, does anybody else have anything that they want to add to the future trends or challenges of incorporating new technologies such as drones and AI? No? Cool. Okay, awesome. So yeah, just a quick reminder to the audience. I know some people have been posting some questions in the chat. If you could please use the Q&A function, that would be really helpful. So that way we can keep it all together. We'll do our best to get everyone's questions answered in the time that we have. But before we do that, let's have our final question, which is going to go to Dominic first. As the broadband or independent networks are more secure. Are broadband or independent networks more secure for IoT network connectivity? Dominic. You're muted.
Okay, muted again, the classic. So this is a pretty good question. I would say the answer is it depends. So, which is of course not a sufficient answer. I really would like to hear Danielle's view on this a bit more because I think she's more of an expert here than I am. Just a few quick thoughts here. What we see also from other industries is that actually the connectivity itself doesn't matter that much as soon, but what is important is you have an encrypted and a secure communication channel that is established in a secure way. So you basically can intercept communication and you can modify anything. So, and also forward secrecy is something that I find is pretty important. So especially if when it comes to using, let's say, cryptographic algorithms, what I observe is that still a lot of old devices still use algorithms that are pretty outdated and actually broken as of today, with not a clear way forward. And also a lot of these old SSL versions, for example, they really do not provide things like forward secrecy, which you want. And I find it concerning when companies or the project leads say, yeah, this is not important information anyway, so we don't need to secure it. I have a pretty strong view on this. You really need to secure any communication that goes outside of any site. This is critical from my point of view. But again, this is something I really would like to hear Danielle's view on that because she's more of an expert than I am.
Awesome. Then yeah, Danielle, would love to have you share your thoughts.
As a cybersecurity person, it depends is our answer for absolutely everything. So there's no hard and fast rules for us, but I would also say neither. I think that the biggest dependency is going to be the scale of your operation, right? And your networking needs are going to have to meet the scale and functionality of what you're wanting to do with your data and connectivity. Beyond that, I would say, again, we need to be really specific and drill in when we're kind of evaluating options. Where do you implement encryption and how well do you do it? Is it on servers and gateways? Is it on all connected devices? Do you have a good descriptor for it? Can you point to it? Can we build trust around those principles? And then again, what exactly is meant by end-to-end? Because a lot of networking capabilities use that buzzword, and end-to-end means something different for everybody. And it may require different configurations and different security features to be enabled or disabled in order to kind of meet the functionality needs again. So neither one is inherently more secure. But again, I think scale is the most important question. And then, what are we securing? Another thing that's interesting that I recommend for any type of procurement, whether it's networking functionality or new technology or hardware, is looking into whether or not that company actually reports on vulnerabilities or speaks to them whatsoever. If a company says 100% of our technology has been secure since 1993, then that's kind of a red flag in my book, actually. The more open dialogue that there are on vulnerability disclosures and mitigations and risk management, the better. So you want to look for that transparency. And then beyond that, there are really interesting new, not new actually, but we're seeing greater implementations across IoT and emerging technology of old hardware authentication, software-defined networking, those kinds of things, and really robust gateway technologies. And I just think that that space is going to be really interesting to watch in the next couple of years for industrial environments. Things like TPMs or trusted platform modules that put a microcontroller or chip, that just authenticates within an environment to devices and networks on the hardware level. I think that that will be an interesting and democratized approach to choosing networks and building networks out. So that's my view. I don't know if it's any more expert than yours, Dominic, but I would look at scale first and then really drill in on security. But that's my spiel.
Thank you, Danielle. And Toby, would you round us out?
Yeah, not much to add there in terms of security. I think that to Danielle's point around scale, what we are seeing is large IOCs where they almost are forced to, where they have large operations in far-flung areas. There's not a dependable public network, so they do run private fiber, and we see that whether it's Gulf of Mexico, North Sea, Western Africa, there's lots of private networks that have been set up really out of necessity based on dependability of the local network. As Dominic mentioned earlier, VSAT traditionally was the way forward, but as you have more and more needs for connectivity to your devices, and as you see an increase of remote operations, certainly we see a lot of private networks be spun up. And we'll see if the low Earth orbit satellite, internet connectivity takes hold and can scale. Obviously, right now it's pretty low bandwidth overall, but we'll see. I think certainly an area we watch closely. So if you're able to kind of offset the need to invest in your own private infrastructure, I think to Danielle's point, if they're equally secure, then certainly going to a public network has its advantages, certainly from a immediate ROI or immediate availability, right? So the ability to use it today versus build your own, obvious advantage. So good question though.
Awesome. Well, thank you, panelists, for that. We're going to open things up for audience Q&A. We have a little less than 10 minutes left, so we'll do our best to get through all the questions. I'm just going to take them from the top down. So the first question that we have is from Thomas was, what kind of project do you guys work on with data with the oil and gas companies? Mostly oil and gas infrastructure or more transitional infrastructure? And we can have Toby kick us off.
I'll give it a try. I mean, we're more on the software side. I think for the most part, the infrastructure is either, it's sort of a longer term where we see kind of big, impactful initiatives. They really are more of a defined by software, but obviously enabled by infrastructure. But glad if anybody else wants to pitch in on that one as well.
Awesome. Dominic or Danielle?
Sure. So I'll just briefly mention, so we work across all the energy segments, not just oil and gas, utilities and more. And we're also looking at transitions to solar, wind, EVs, et cetera. And so typically I describe this, our approach to working with clients as anything and everything emerging technology that's in the energy industry, we look at as a revolution, and we need to secure all of that. And I'm a security person that comes in and works on data integration, networking, and cybersecurity for that revolution. But then we can't forget the OT, which is experiencing a renaissance, not a revolution. People are not ripping and replacing their OT systems there. It's a renaissance in terms of how we go and look at SCADA and ICS and secure those things. And so that's the dichotomy that I like to paint that picture for. The same goes for oil and gas, even though they get a lot of the security stuff pretty right now. So they're kind of between the renaissance and the revolution, right? Kind of building out new functionality on top of doing really good segmentation, but then, wanting to incorporate, maybe drones that fly over their well pads and then synthesize that data. And then, how do we integrate that to some of the OT legacy systems? And so that's where I work on. That's the plane that I am most comfortable in.
Awesome. Thank you. And Dominic.
Yes, similar with us. So we are serving a lot of different use cases here with data architectures and publish subscribe architectures. So oil and gas is something that we have a lot of customers right now in this segment, but also we have customers who are more in the energy sector, also companies who for example, in Finland, here in Europe, a company who basically built a private power grid for renewable energies. And so you have similar to what Tesla does, you have this private power grid, and all these things are enabled by this real-time publish-subscribe architectures, and this is what we're doing. So we are not industry specific here, but what I personally always find important is that because every industry is different and has different needs and also different challenges, and so we're working very closely together with the customers to basically solve all these challenges, but also, for example, as the drone were mentioned, so to also bring in new technology like drones and so on, and also bring this into a, let's say, global centralized data architecture. So this is the work we're doing. So we're not hyper-focused on a very specific part of the energy sector.
Joyce, can I also
Okay.
add that groups like, I think
Yeah.
Toby and mine, we're vendor agnostic. So a lot of times software providers and vendors for oil and gas as a market will come to us and then do an exploratory analysis of how they can enhance their asset management software and utilization and things like that. And so I love being vendor agnostic because I can go in and kind of analyze the entire breadth of the market and say who's doing what well and why. So I believe that's true for Toby too, but I don't want to speak for him.
Absolutely, yeah.
So then, you know, oil and gas would not be our client in that sense, but the vendor that provides software to the oil and gas market will come to us for robust analysis and you know, kinds of secondary research and primary research throughout the industry. And the same goes for cloud computing. So transitioning to adopting the cloud, we'll go out and do kind of a robust field investigation of the vendors in that space. So I wanted to add that point.
No, thank you for that. Appreciate it. The next question we have is, what is the main difference in industrial IoT technology and the digital transformation of utilities and manufacturing? Anybody want to jump at that one?
So yeah, this is a surprisingly large question to answer, because actually different industries operate quite differently. But I think a few challenges are the same and a few are different. So for example, when you in manufacturing, for example, we're also doing a lot of work here. You usually don't have that remote areas you want to cover, because usually factories, for example, they have a pretty solid infrastructure. This is, I believe, a key difference, at least what we've seen. When it comes to connecting the things to the cloud, like a whole factory, the challenges are pretty similar. I would add one difference. Usually you also have this kind of segmentation also inside a factory. So you have security is pretty important here. And so you have this kind of network segmentations and so on. So you have really multi-tiered architectures, but it depends on the sophistication of actually the customer and their operations people.
Thank you. Toby or Danielle?
Sorry, so the question, what's the difference in technologies between like critical infrastructure verticals, basically?
It says the digital transformation of utilities and manufacturing. So
Utilities
you
and
slice that however you like.
Yeah, so I mean, I could go on all day about the differences between IT and OT systems, but I think what's most important for this is the differences we see is what's virtualized versus what's like real time, right? So what are you remotely actually altering and adjusting versus what are you just virtually witnessing and you have no direct action in the process or the function? That's a big difference. And then also what's automated, right? That's going to be very different in a manufacturing plant versus some, you know, extraction site. What process you're automating might be a sensor reading or it might be an actual physical process. So those are my two, you know, big picture, high level responses is what's virtualized versus what's real time and what's automated will vary, very differently across different operations.
Awesome. Thank you. Toby, do you have anything to add?
No. We do certainly see differences if the question's about among different verticals. Certainly just the application is different, but what we see is common platform approaches, right? And similar patterns across different industries and use cases.
Awesome. Thank you. Just this question really quickly, is the recorded version going to be available later? If you've registered for this, I have a good feeling that they're going to send out recordings after the fact. So probably within the next week, you should have an email being able to access the links, if not sooner than that. And then the final question, we only have about a minute, so we'll try to do this as quickly as possible. Where in time the industrial IoT is, can it improve the velocity of the internet connection of offshore to allow proper software and application to be used on board?
Excellent. Dominic, maybe is that the MQTT type example that you've got new technologies that sort of optimize lower bandwidth and higher latency connections. You're on mute.
I'm not quite sure actually where this question is targeted at. This could be a possible answer here, that technologies like MQTT, which are extremely efficient, can be used here and can make a better use of your connectivity. But in the end, if your connectivity is really bad, this is the baseline, right? You cannot get better than your connectivity is. But what you can do is you can use as low overhead as possible by using MQTT with spark plug architectures. But yeah, this would probably also be a question that would need a bit more time to elaborate on.
Fair enough.
I'll just add that you can actually find that analysis online if you go and look for kind of leaderboards and different analysis of vendors in that space. There are, I know of comparisons that exist for specifically IIoT remote connectivity. I don't want to promote any one company's work, but if you go and look for them, I know that people have done that analysis.
Awesome, thank you. Toby?
Yeah, nothing to add there. I think we've certainly accommodated different use cases and different implementations of good and bad, right? From VSAT to full fiber. I think you've got to make sure your solutions can accommodate fault tolerance.
Awesome. Okay, well, thank you so much. I think that's all the time that we have for questions today. A huge thank you to the audience for attending, as well as for being super engaged in the chat and the Q&A. And a thank you again to our panelists for participating with us. I think they gave us some really wonderful insights. And a special thank you again to HiveMQ for sponsoring today's session. We really appreciate the opportunity to speak with you all today. Just so you know, you have a couple of additional sessions coming up here shortly. So definitely stay tuned and stay engaged with what's happening in IIoT world and their Energy Day. And with that, thank you so much.